looking through some more further Pure 2 revision now, we're going to take a brief look at the Cayley Hamilton Theorem. So it's quite a brief chapter. It's from chapter 5 of the official Edexcel for Pure Maths 2 textbook, and it's just a brief part within chapter 5. So I'll have a look at some questions today from the textbook. I've not picked any of the questions out from the exams because there's not many questions to pick from, and I don't really want to take away from the actual exam revision that teachers might use in schools and sixth forms. So just using questions from the textbook, let's have a look at some of these questions. So we'll get the right pen. Let's have a look at this one here, question 2. So we've been given a matrix A, which is 6, 2, minus 1, and 3. Okay. Now part A just asks us to find the characteristic equation of A. So to find the characteristic equation of A, what we have to do first is we need to subtract off the identity matrix multiplied by lambda. Okay, so that's using lambda as a scalar. So what I mean by that is we're going to work out the determinant of A minus lambda I. Okay, so that'll be the determinant of, it'll be 6, 2, minus 1, 3, minus, so it'd be the identity matrix, but whether it normally be at 1, it will just be lambda. So lambda 0, 0, lambda. So once we've done that subtraction, then we need to work out the determinant, okay? So this will be the determinant of 6 minus lambda, 2, minus 1, and then 3 minus lambda, okay? So hopefully nice and easy so far. Now we need to work out the determinant of this 2 by 2 matrix here. And once we've worked out that determinant, we set it equal to 0, and that gives us our characteristic equation. So working out the determinant here should hopefully be straightforward. I'm going to do 6 minus lambda times the diagonal opposite, so 3 minus lambda, or the opposite element, 3 minus lambda, and then I do minus, so it'd be 2 times minus 1, and this is all equal to 0, okay? So 6 times 3, that's 18. 6 times minus lambda, so that gives me minus 6 lambda. Then we do minus lambda times 3, so I get another minus multiple of lambda, so minus 3 lambda. And then finally, minus lambda times minus lambda gives me positive lambda squared. And then we've got minus 2 times minus 1, so that would be minus 2. And then minus minus 2, that would give me plus 2 there. And all of that is equal to 0. Okay, so we can simplify here, and we've got our characteristic equation. Simply all we've got to do. So lambda squared, there's no other lambda squared, so it'll just be lambda squared. I've got minus 6 lambda minus another 3 lambda, so that'll be minus 9 lambda. And now I've got 18 plus 2 gives me plus 20, and that is all equal to 0. So this equation here, the lambda squared, that's our characteristic equation of A there. Okay, so that's part A done. So that was part A. Now in part B, it's a hence question, so remember with a hence question we want to use the previous part to help us solve this. So hence show that A cubed is equal to 61A minus 180I. So let's have a go at this. What I'm going to do is I'm just going to clear this. I'm going to write my characteristic equation down again. So if we just clear all this. So we just got my pen back. So if we remember the characteristic equation, we just wrote it down, so that was lambda squared. It was lambda squared minus 9 lambda plus 20 is equal to 0. Okay, so we use this now. Now we can apply the Cayley Hamilton theorem. So applying Cayley Hamilton theorem. So with the Cayley Hamilton theorem, wherever there's a lambda, we replace that with an A, and wherever there's a number on its own, that would be multiplied by I. So to do that, we just write A squared minus 9A, and because it's just a number on its own, it'll be 20I. Okay, so we've applied the Cayley Hamilton theorem. Now we want A cubed. Now I've got A squared minus 9A plus 20I. So it might not be immediately clear, but if I've got an A squared, if I could rearrange this in terms of A squared, all I have to do then is multiply through by A. So let's try rearranging this. So this is equal to 0. So we can write that as A squared is equal to 9A minus 20I. So now we've got it in terms of A squared. Well, I want A cubed, so to get A cubed, all I've got to do is times both sides by A. Okay, so times left hand side by a times the right hand side by a, we get a cubed. So if you've got 9a and you times it by a, that'd give us 9a squared. And if you had minus 20 lots of the identity and then you times it by a, what that would give you is just minus 20a. Okay, remember the identity matrix essentially acts as the number 1 in terms of matrices, so I've got minus 28 there. But that's not quite what we want. We want a cubed is equal to 61a minus 180i, whereas we've got 9a squared minus 20a. So we're going to need to do a little bit more with this to get it into the correct form. Well, remember, we have this here. This is in terms of a squared. So in terms of a squared, and because it's in terms of a squared, where I've got an a squared here now, I can just substitute that in. So a cubed is equal to 9 lots of a squared, and a squared is 9a minus 20i. Okay, and we've got the minus 28 at the very end, so don't miss that off. So now all we've got to do is simplify this, and hopefully once we simplify this, we should get the 61a minus 180i. So a cubed is equal to 9 times 9a, so that'd be 81a. 9 times minus 20i, so that'd be minus 180i. And we've got a minus 20a at the very end there. And if we simplify this one step further, we can write a cubed is equal to 81a minus 20a, so that'd be 61a minus 180i, just as required. So there we have it. So that's a cubed equal to 61a minus 180i. So that gives us all 5 marks there for question 2. So this was from exercise 5D, so you can follow along at the top if you want to carry on working through them. But that's that question there, fully complete. So let's move on to the next one. So this is from the same exercise. This is question 4, sorry. And what we've got here is we've got another 2x2 matrix, and we're just asked to find the values of p and q such that a is equal to pa squared plus qi. So 3 marks for this. Let's start by writing down our matrix. So A is 6, 3, 0, and 4. Well, just like we've done with the previous one, we're going to need to get this in terms of the characteristic equation. So to get that, I need to do this by doing A minus lambda I, and then work out the determinant. So if I kind of skip ahead and do the A minus lambda I, that would be just simply 6 minus lambda and then 4 minus lambda. So it's the diagonals where you subtract the lambda off. So we need to work out the determinant of 6 minus lambda, 3, 0, and then 4 minus lambda. Okay. Working out the determinant of this now. So 6 minus lambda times 4 minus lambda minus 3 times 0, so that'll just be minus 0. So that's just going to be equal to 0. Okay, we need to expand these double brackets here now, so that'll be 24. 6 times minus lambda, that'll be minus 6 lambda there, sorry. So minus 6 lambda. Minus lambda times 4, so that'll be minus 4 lambda. And then minus lambda times minus lambda will be lambda squared like that. And that's all equal to 0. So we can simplify this now. So lambda squared minus 6 lambda minus another 4 lambda, so that's minus 10 lambda plus 24 is equal to 0. Okay. So that's our characteristic equation. Now we need to use the Cayley Hamilton Theorem. And we know we need to use the Cayley Hamilton Theorem because it's in terms of A and I here. So using the Cayley Hamilton Theorem, we can rewrite this now as being, and because it's in terms of A, it'll be A squared minus 10A plus 24, and because it's just 24, it'd be 24i. This is equal to 0. Now, simply, I just want this in terms of A. So it's A is equal to some multiple of A squared plus another multiple of I. So all I need to do now is rearrange this to be in terms of A. So simply, all I've got to do is say it's minus 10A across by adding 10A to both sides. So 10A is going to be equal, so that'll be positive A squared plus 24i. So A squared plus 24i. And because we want it to just be A equals, this is 10A, all I'm going to have to do is divide by 10. So do this up here. Divide through by 10. So dividing by 10. What that'll give us is a is equal to 1 over 10 a squared, and then it'll be plus 24 over 10 I. Okay, and it just wants us to find the values of p and q, so simply we just need to write p, well, that'll be equal to the number in front of the a squared, so that'll be the 1 over 10, and then my q is my coefficient of my I, which is 24 over 10. 24 over 10, or we can simplify that to be 12 over 5. Okay, or you can give it as 0.1 and 2.4 if you really want, but that'll do there, that's absolutely fine. So 3 marks for that. I don't think there's anything too tricky. Hopefully all makes sense. So let's move on to the next one. So we've got another question here, very similar to the first one that we actually did. So again, another 2 by 2 matrix. We have to find the characteristic equation of A, and then another one, another hence question to find A cubed. So let's jump straight into this. And again, guys, if you've not done a question like this before, have a go at it now, pause the video. Once you've had a go at it, start the video again and see if you get the correct solution. So, question AA. So let's work out our characteristic equation. Remember, we've got the matrix A, we need to subtract lambda I off. So, with enough practice, you'll just get very quick at this, you'll just start doing it straight away. But my A minus lambda I, so we need to work out the determinant of A minus lambda I. So that's going to be the determinant of 4 minus lambda, 5 minus 1, and then 2 minus lambda. Okay. So, working out the determinant of this now. It's to be 4 minus lambda times 2 minus lambda, and then minus 5 times minus 1. Okay, this is all equal to 0. So 4 times 2, that gives me 8. 4 times minus lambda, I get minus 4 lambda. Minus lambda times 2, so I get a minus 2 lambda. And then minus lambda times minus lambda, I get lambda squared. We've also got this minus bit here, so minus 5 times minus 1, so that would be minus 5. Minus minus 5, so that's plus 5 there. And that's all equal to 0. So we need to just simplify here, and we've got our characteristic equation. So lambda squared, minus 4 lambda minus 2 lambda, so that would be minus 6 lambda. Positive 8 plus 5, that would be 13 there. Okay, and that's all equal to 0. So that's our characteristic equation. Now we need to use this here, this characteristic equation, to show that A cubed is equal to 23A minus 78I. Okay, so we'll see if we can squeeze it on at the very end. So using the Cayley Hamilton Theorem now. So using, I'd always make note of this, guys, when you're doing these questions. Always just write down a little line saying applying the Cayley Hamilton Theorem or using Cayley Hamilton Theorem, just so your examiner is clear what you're doing. This would be now, because it's in terms of A again, it'll be A squared minus 6A plus 13I. So remember, if it's a number here, it'll be 13I. This is equal to 0. So again, we want A cubed, so a nice way of doing that would be get it in terms of A squared and then multiply through by A. So we can do that again here. A squared is equal to 6A minus 13I. Timing through by A now. What that'll give me A cubed. 6A times by A, so that'd be 6A squared. And then minus 13I times by A, that'd just be the same as minus 13A there. Okay. Now, we haven't quite got it in the form they want, so we need to substitute something in, and that something is going to be my A squared here. So sub this in into, we'll call it equation 2 here. So that's equation 2. So we're going to sub equation 1 here into equation 2. So what will that give us? That'll give us A cubed is equal to 6 lots of A squared, and A squared is 6A minus 13I. So 6A minus 13I. And then we've got minus 13A at the end here. So just make sure you don't forget this, otherwise you're going to get something slightly different to what they want. So therefore, we can simplify this. A cubed is going to be equal to 6 times 6A, so that'll be 36A. 6 times minus 13I. So that'll be minus 78i minus 13a. Okay. Now if you simplify this one step further, all we've got to do is subtract 13a off 36a. So what that'll actually give us is a 23a. So 23a minus 78i there. And 3 marks for that part B, 5 marks overall for the full question. So these are very standard questions. The only way these can really get trickier would be a 3x3 matrix. And if it is a 3x3 matrix, it won't be a quadratic like we've got here. What it'll be is it'll be a cubic polynomial. And that's the only difference. So they're all pretty standard like this. But we've got one more question to finish off with. So let's have a go at that. This is exercise 5D, question 3. So we're given a matrix here, M, which is 4 minus 2 is 0, 6. So part A wants us to find the characteristic equation of M. And another good little thing you can do with the Cayley Hamilton Theorem is find the inverse of a matrix. And that's what part B wants us to do. So, question 3A. It wants us to find the characteristic equation of M. So, let's do that. So again, straight away, we need to do the determinant of M minus lambda I. So that would be equal to the determinant of 4 minus lambda minus 2, 0, and then 6 minus lambda. So that would be the same as doing 4 minus lambda times 6 minus lambda minus, it'd be minus 2 times 0, so that'd just be 0. So we know this has to be equal to 0 now. Okay. 4 times 6, that'd be 24. 4 times minus lambda, so that'd be minus 4 lambda. Minus lambda times 6, that'd be minus 6 lambda. And then finally, minus lambda times minus lambda, so minus lambda squared. But obviously, because it's minus lambda times minus lambda, it'll be positive lambda squared. Okay. And this is equal to 0 now. So we need to simplify here. So this will be lambda squared. Minus 4 lambda minus another 6 lambda, so that'll be minus 10 lambda there. And then finally, we've got the plus 24 at the very end. Okay. That's all equal to 0. It's as easy as that. But honestly, with enough practice, you'll get one of these questions, and you'll be hoping for one of these questions basically on your exam. Nice and easy. And then part B, it's a hence question, so we need to use part A. Use the Cayley Hamilton Theorem to find M inverse. So it gives us a big clue in saying use the Cayley Hamilton Theorem. So if I write this in terms of B now, if I write this part B, we need to find M inverse. So we need to apply the Cayley Hamilton Theorem. So using Cayley Hamilton Theorem, we can rewrite this now as being, now it's in terms of M, so let's write it as M squared minus 10M plus 24I. And this is equal to 0. Now we want M inverse. So the easiest way to get this M inverse would be to get this in terms of being I, so rearrange for this to be 24I, and then times through by M inverse, because we've got it in terms of M inverse then. So rearrange for M inverse. So it'd be 24I, and then times by M inverse. Okay, so if I rearrange this now to 24I, the 24I is equal to 10M minus M squared. Well, if I times both sides now by M inverse, this is going to be in terms of M inverse now, because remember the identity matrix essentially acts as 1. So I'm going to do 24I times M inverse, which is equal to 10M times M inverse minus M squared times M inverse. Okay, remember when you time through like this, when we're timing through by M inverse, we multiply each part of this by M inverse. So if you've got 24 lots of the identity and you time it by M inverse, this is just the same as 24 M inverse. 10M times M inverse. Well, these essentially just cancel out to give you the identity, so you get 10 lots of the identity, and then minus M squared times M inverse, that'll just give you minus M. Okay, now we want this to just be M inverse, so we're going to have to divide through by 24 here, so this will be M inverse is equal to 1 over 24 lots of 10i minus m. But we know what I is. That's just a 2 by 2 identity matrix. Well, we definitely know it's 2 by 2 for this one because we're working with a 2 by 2 matrix. And m is what we got in the question here. So this is 1 over 24. Doing a bracket here. 10 lots of the identity, so that'd be 10, 0, 0, 10. So 10, 0, 0, 10. Minus m, which is 4. Minus 2, 0, and 6. Okay, we can close that bracket. Well, 10 minus 4, that'd be 6. So what this is now is 1 over 24 lots of 10 minus 4, so that's 6. 0 minus 2, so that'll be plus 2. 0 minus 0, so that's 0. And then finally 10 minus 6 gives me 4 there. Okay, so this is m inverse. So you could write it like this, but we can simplify this because it's 1 over 24. This will work out not too bad. So if I just do it all the way up at the top here, so m inverse, so this will be your final answer now. So m inverse is going to be equal to 1 over 24 times 6. So that will give me 1 over 4. Couldn't do maths then, so 1 over 4. Then I've got 1 over 24 times 2, so that'll be 2 over 24 or 1 over 12. That'll be 0. And then finally 1 over 24 times 4 would be the same as 1 over 6. Okay, so that's my final answer there. Okay, but I hope this has helped. That's the end of the questions for this video. If there's anything that's unclear, please leave a comment. Any feedback, anything like that, it's greatly appreciated.